Hi, we are starting the very first lecture with Analytical Chemistry 301. So, analytical problems and procedures for quantitative analysis can be described by number of flow charts. One of flow charts you can see in your textbook. Here I'm presenting a very similar one. So we are starting with definition of the problem. What we are going to do? What kind of results we want to obtain? What our customer wants us to do? Because analytical chemistry is service discipline. We rely pretty much on opinion of our customers. So when we know the problem, we are coming to choice of technique we are applying to this problem. What kind of techniques we can use? Of course, only those that are available for our labs. The fact that there is a fancy procedure that other people do doesn't mean that you have it here. So you need to know all the techniques available in your lab and apply them properly. Next is sampling. Sampling is fantastically important. If you take a wrong sample, you'll receive the wrong result. Garbage in, garbage out. This rule works nicely here. Sampling is a very special area in your textbook. It's practically a large chapter dedicated to this issue. Now, you need to pre-treat sample, mostly to bring it into solution. It can be dissolving, it can be digestion. There are plenty of other methods. Here you may make some preliminary tests to see how much of your analyte is in the sample. Then you perform the measurement. That's what we name quantitative analysis. And process your results and then report your results. At the end, you want to review original problem to figure out if your results makes any sense, if they need to be reconsidered, if there is another problem coming from your results. Okay, let's look at some down-to-earth example. We want to figure out how much caffeine is in our chocolate. Well, chocolates can be different. It can be dark chocolate, milk chocolate, different brands. So perhaps they have different amount of caffeine inside. How will go? First, what stands for caffeine? The main active ingredient in chocolate is theobromine. It's alkaloid, having several nitrogen and carbon atoms and aromatic rings. Next, caffeine is methylated theobromine, so one methyl group instead of hydrogen atom in this position. In fact, most of caffeine you have in your caffeinated drink is synthetic, coming from methylation of theobromine recovered from cocoa beans. So what we do with our chocolate? We take some sample. It should be bulk representative sample, so several grams of it. crush it, and make it homogeneous. Now we want to take several parallels of this sample. Parallel, uh, Parallels of that sort, so amount taken from the same sample we name aliquots. We'll use this word very frequently. Now, chocolate is insoluble in water and it has lots of fat, which is cocoa butter. We need to remove this fat. The easiest way is to put finely ground chocolate and add some organic solvent. The cheapest would be petroleum ether. You can put hexane or heptane instead. Shake it well. Now, cocoa butter will dissolve in petroleum ether. Alkaloids and sugars will not. So after this centrifuge, we'll have solvent with dissolved fat and solid residue of sugars, alkaloids and other material on the bottom of the tube. So we'll have defatted residue on the bottom. Next, we'll put this residue in a boiling water. Boiling water, most of polymeric organic material will still be insoluble, but alkaloids, caffeine and theobromine will go into water, will dissolve. Now next, we want to remove these solids from our solution. So we again centrifuge, leaving insoluble chocolate residue on the bottom. The liquid above still contains tiny particles that we want to remove. So we'll filter this aqueous solution. In industry, we seldom use the filters you are familiar with. The best idea for this will be using syringe filter, like on this image. So we apply brutal pressure by hand and push the liquid, which is aqueous solution with some dissolved analytes, down. Here I have no solids. I'll have perhaps some sugars, and I have my theobromine and caffeine. How can I figure out contents? I need to do chromatography. So the idea is that compounds that will come into chromatographic column will be absorbed by silica or other bounding material here, and then when they are coming out from the column will be detected by UV detector. So you are putting your solution on the top, and then caffeine and theobromine are coming out at different rates, and other compounds will come out at different time. So you have plenty of peaks on your output. Let's look how it look like. So that's our output. Some noise coming from foreign compounds we do not know about. Large peak of theobromine, then some other peaks, again we don't know what that, and then another relatively large peak of caffeine. For doing that, we are not using columns. We are using a sophisticated device like that with computer attached. That's how we are getting this complex picture. Now we want to calibrate our system. We see the peaks, but we do not know how much theobromine and caffeine are in this. So we make solution with known amount of theobromine and known amount of caffeine and running it through our systems. Now we know which amount of theobromine and which amount of caffeine corresponds to these two peaks. How we know that? Because we made solution ourselves. So we make a calibration for caffeine and for theobromine, and then from our points we figure out our unknowns here and there. Okay, so here are the results. For dark chocolate we have pretty much of theobromine and much smaller concentration of caffeine. For white chocolate we have practically nothing of two of them. I don't know why they name it chocolate, as a matter of fact. Well, let's look at our problem as a part of general, as how much caffeine you can find in different places. Regular coffee, around 100 milligrams per serving. In your usual chocolate, you'll have 20-30. In caffeinated soft drinks, you have 30-50, but energy drinks will have as much as regular coffee has. So that's how we did it. We started with problem, we took sample, we process it, we received results, we analyze them, and we look at results in our report.